All right, we're going to look at volume and surface area. So I've listed out the shapes that I want to put the formulas for. And this is kind of like the area ones, where this first page is going to be a formula sheet, and then we're just going to do a bunch of examples. So I'm going to write out the formulas first, and then we'll just do some examples. So generally, for prisms, the volume is going to be big B times H, where big B is the area of the base. So if you have a triangular prism, then the base is a triangle. So we do the area of the triangle times the height. And then the surface area, see if I can do a general one. Surface area. So surface area is like if I flatten the image. So if I use this idea of a triangular prism, I'm going to try and draw one. So it's like if I flatten it. So I would have a triangle, and then I'd have 1, 2, 3 rectangles. And then I have a second triangle. So I'm finding all the areas of the little shapes. So I'd have 2 times the area of the base. And then I'd have the area of these rectangles. So I have 3 rectangles. And what do I want to call it? Let's see. I guess I can use P for like, it's the perimeter of the triangle, and it's those shapes. But it's going to change for each type of prism, because a rectangular prism, if I draw one of those, I'm going to have 2 bases that are rectangles, but then I'm going to have 1, 2, 3, 4 of those perimeter ones. So it depends on the shape of the prism, or the base. Oh, so that's what I put. Depends on base shape. So for a cube, let's try and draw that. So volume of a cube, it's a square prism. So we have the base being a square. So we'd have a side times a side. And then you multiply it by the length, which, because it's a cube, all of it's the same. So side cubed. And then the surface area, all of these are squares. So there's 2 squares on the front and back, and then there's 4 all around it. So total there's 6. So there's 6 squares. And then the area of this square, if I use the side length as an S, is s squared. All right, a sphere. Let's see if I can, I don't know if I can draw a sphere. It kind of looks 3D. So the volume of a sphere is 4/3 pi r cubed. And then the surface area is 4 pi r squared. We have a cone. Looks something kind of like that. We have a radius of the circle, and then we have like a height of the cone. So volume of a cone is 1/3, and then area of the base, which is the circle, and then times the height. And then the surface area, if I flatten it out, it is a circle, and then it's a circle, and then a weird, like, curved triangle. So not really a triangle. I guess part of a circle, I guess I could say. So the surface area for that is there's actually two ways we can look at the surface area of a cone. So we need what's called the slant height. So I'm going to put that here. I'm going to say S for slant height. So we could say that the surface area of the cone is pi r squared plus pi r s for slant height. So we see this makes a little triangle here, right? So we know that this is the height of the cone and this is the radius. So to find the slant height, we'd use Pythagorean theorem. So s squared equals h squared plus r squared. So if I really wanted to substitute in for s so that I don't have to like do the Pythagorean theorem every time, I can. So the slant height, if I were to solve for s in that formula, is the square root of h squared plus r squared. That way I only am working with the height and radius if the slant height's not already given. And then a cylinder, the volume is the area of the base times the height. And you know what? I should go ahead and just put both of those in. So it's a circle, so pi r squared height. Same thing with a cylinder. The base is a circle. So pi r squared times the height. And then surface area, I have two circles. So 2 times the area of a circle, 2 pi r squared. And if I flatten it out, I have a circle, and then a rectangle, and then another circle. So that rectangle, to do that area, the side length here is actually the circumference of the circle. So 2 pi r. And then the length of the other side on this rectangle is some height or length. So I need to do the area of, or not the area, the circumference of the circle times the length of the cylinder. And then for a pyramid, and I'll say a square pyramid, so that's the base is a square. The volume is 1/3 area of the base. So in this case, it's a square. So if I do sides, S for sides, side squared, and then times the height. And then the surface area is the area of all those surfaces. So we have a square. And then in this case, there's 4 triangles. So let's see, triangle is base times height divided by 2. I wonder if we can clean this up a little. Let's see, the base is the side of the square. So I can replace that with S. And then the 4 and the 2 can reduce because 4 divided by 2 is 2. And then go from there. Let's actually look at some examples with all of these. So you're going to find the volume and surface area for each of these figures. So for a sphere, do volume here and surface area here. Don't know if I left enough space. But volume of a sphere is 4/3 pi r cubed. So it gives us the diameter is 4, which means the radius is 2. So volume is 4/3. We'll go ahead and throw in 3.14 in for pi. And then r is cubed, so 2 cubed. And then I can put this in a calculator. So 4/3 times 3.14 times 2 cubed. So that's 2 times 2 times 2. And I get 33.493 repeating. So we could round that and just say 33.5. And let's see, it's in meters. And volume is cubed. And the surface area is 4 pi r squared. So 4 times 3.14 times 2 squared. So 4 times 3.14 times 2 squared. And I get 50.24 meters squared. All right. We have I don't know what I want to call this because I have this 4 centimeters here. So this right here is 5. This one's 5. This one's 5. This one's 5. And this is 4. So I call that a rectangular prism. So I have this base here and here. That's a square. So volume is area of the base. So the base is a square. So 5 times 5. And then times its depth. Times 4. 5 times 5 times 4 is 100. So 100 centimeters cubed. And then the surface area is really just adding up all the bases, or adding up all the surfaces. So 2 of the squares are 5 by 5. 2 times 5 times 5. And then I have 4 other ones. 1, 2, 3, 4. that are 4 by 5. So 2 times 25 plus 4 times 20. So 50 plus 80. And that'll give me 130 centimeters cubed, or squared. All right, we've got a cone. So the volume of a cone is 1/3 area of the base. The base is a circle, so pi r squared. And then times the height. Now, this wasn't a very good example. This one doesn't give the height. I can find it, though, because it gives me the slant height. So the height squared plus the radius squared is the slant height. So h squared plus radius squared plus, or equals the slant height, 17.9 squared. And then I can solve for h. So I can take the 17.9 and square it. And that gets me 320.41. And then I can subtract off 8 squared, which is 64. So h squared is 256.41. And then I had to do the square root of that. So h is, and I'll round it, it's 16.0128. Let's just go with 16. So the volume is 1/3 pi, 3.14, r squared, which is 8. And then the height is what I just found, so 16. And I can throw that in a calculator. So 1/3 times pi times r squared times 16. So this is a really large number. I get 1071.78 and then 6 repeating. We'll just say 1071.9 centimeters cubed. And then the surface area is pi r squared plus pi rs. So 3.14 times the radius squared. And then plus 3.14 times 8 times the slant height, which is that 17.9. I'm running into the other shape here. And we'll throw that into a calculator. So 3.14 times 8 squared plus 3.14 times 8 times 17.9. So I get 650.608 centimeters squared. I have a rectangular prism here. So volume is area of the base, which is length times width. So 6 times 3, and then times the depth, which is 6. So 6 times 3 times 6 is 108. And then the surface area is the area of all the faces. So I have 2 rectangles that are 6 by 3. And then I have 4 rectangles that are actually, I have 4 rectangles that are 6 by 3. And 2 that are 6 by 6. So it'll give me 4 times 18 and 2 times 36 for a total of 144 meters squared. All right, now I have a pyramid. So volume is the area of the base, or 1/3 times the area of the base, which is a square, and then times the height. All right, so this gives me a height of the triangle and not the height of the actual like pyramid. So I'm going to make up a number here. So the height of the actual pyramid, let's make it 10. Yeah, we'll make it 10. So 1/3 area of the base is 7 by 7. And then the height of the pyramid is what I made up, 10. So I can throw that in a calculator. 1/3 times 7 times 7 times 10 gets me 163.3 repeating. So we can just say 163.3 feet cubed. And then the surface area is the area of the base. So that's square. This is 7 times 7. And then I have 4 triangles. So 4 triangles, and the area of a triangle is base times height divided by 2. So the base is 7. The height of the triangle is 8.7. And then we divide by 2. And then we can plug this in. So 7 times 7 plus, and then the other one. And I get 170.8 feet squared. Now I have a cylinder. So the volume of a cylinder is the area of a circle, so pi r squared, and then times the height. So 3.14 times the radius. It gives me the diameter. So the radius is 10. So 10 squared. And then the height is 13. So 3.14 times 10 squared times 13. I get 4,082 meters cubed. And then the surface area is, we have 2 circles, so 2 pi r. And then we would have 2 rectangles, or 1 rectangle, which is the circumference of the circle, so 2 pi r, and then times the height. So 2 times 3.14 times the radius plus 2 times 3.14 times the radius times the height. So 2 times 3.14 times 10 plus 2 times 3.14 times 10 times 13. And so I get 879.2 meters squared. And 2 more shapes here. So I have a triangular prism here. So the volume is the area of the base. In this case, base times height divided by 2. And then times the height of the prism. Or like the length, I should say. So for the triangle, because it's a right triangle here, the base is 3. The height is 4. And then we'll divide that by 2. And then the distance of this, like depth of the prism, is 7. Then we'd have 3 times 4, which is 12, divided by 2 is 6, and 6 times 7 is 42 meters cubed. And then the surface area, we'd have the area of the triangle, so base times height divided by 2, but then times 2, because I have 2 of those triangles. And then I have 3 rectangles. So this rectangle here is 4 by 7. This rectangle here is 3 by 7. And then the last triangle on the bottom is a 5 by 7. Oh, I didn't even put in the base and the height of the triangle. It's 3 by 4. So let's see. These 2's are going to cancel out. So I'm left with 3 times 4. So 12. 4 times 7 is 28. 3 times 7 is 21. And then 5 times 7 is 35. So 12 plus 28 plus 21 plus 35. And that gives me 96 meters squared. All right. Then we have this pentagonal prism. All right. Surface area might be the easiest one to do first, so I'm going to do that. So surface area is going to be 2 times the area of the base, which I'll probably have to look up the formula for area of a pentagon. And then we have 1, 2, 3, 4, 5 rectangles. So 5 rectangles that are 12 by 8. Right, and then I need to look up the area of a pentagon because I don't know that off the top of my head. All right, the area of a pentagon. Area pentagon is 1/2 times the perimeter times the apothem. The apothem is this piece here. So we'd have 1/2 times 8.3 and then times the perimeter. Well, if it's 12, 12 times 5 is 60. So I will write that here. 1/2 times 60 times 8.3. So now we'll just throw that in a calculator. So 2 and then times 1/2 times 60 times 8.3 plus 5 times 12 times 8. So I get 978 yards squared. So then the volume is going to be the area of that pentagon. So that was the 1/2 times 60 times 8.3. And then times this height here, which is 8. So I get 1/2 times 60 times 8.3 times 8. So 1992 yards cubed. And that is all for volume and surface area. So if you have any questions, let me know.